Hi everyone, good evening. Thank you for joining us today and welcome to Fast and Easy Machine Learning with Python, presented by Python Colombo and conducted by Dulaj Disanayaka of Gapstars. Today, Dulaj will be taking you through the basics of machine learning along with all of its paradigms. So without further ado, I'd like to pass the stage on to Dulaj for him to begin his session. As always, guys, if you do have any questions, do drop them into the Q&A box that you see at the bottom of your screen. And we will be taking your questions at the end in our live Q&A session. If you do have any other comments or any other suggestions or any other questions for the organizers or for me, do drop them into the chat and I will get to you as soon as I can. Dulaj, the stage is yours.
Thank you, Sarah. Hope everyone can hear me and see my screen. Welcome to Fast and Easy Machine Learning with Python. My name is Dulaj Disanayaka. I'm a software architect at Gapstars and an MSc in data science. So first of all, let's discuss what we are going to discuss today and achieve today. Since this is actually a beginnerless session, we will take a look at what AI and machine learning and deep learning, these keywords are, what neural networks are, and we will be discussing what a classification problem is, and more specifically what an image classification problem is. We'll also briefly discuss a very powerful concept in machine learning, which is called transfer learning, and how we can use transfer learning to train a very complex model with using very small amount of data. With the gathered information on our introduction, we'll do a hands-on session where we define a very small problem and gather the data required to solve that problem, set up our environment, implement a neural network, train it, and deploy it. If you have any questions whilst on the presentation or on our hands-on session, you can ask away on our Q&A on this session, and I'll answer them later. First of all, let's discuss what is what in machine learning. First of all, artificial intelligence is actually a very broad concept where digital computers can learn to do tasks that are done by more intelligent beings. So the artificial intelligence is actually a very broad concept that define any application or solution that falls down into the explanation that I have given. Machine learning is actually a subset of artificial intelligence where you use pre-existing or synthetic data to solve this problem of artificial intelligence. Recently, you might have heard the word deep learning. Deep learning is actually a subset of machine learning where you use complex machine learning models to solve complicated real-world problems that regular machine learning models can't. Data science, which also is a keyword that's going around, is actually a little bit different from artificial intelligence because data science takes a look at problems in the perspective of data. So data gathering, data cleanup, data governance, data storage, as well as using the data to generate insights and train machine learning models. All of these concepts around data falls down to data science. So data science has some overlap between artificial intelligence, but there are some other areas in data science that are not included in the practices of artificial intelligence. When we go a little bit deeper into machine learning specifically, there's a quite popular method of solving machine learning problems we are using today, which are called neural networks. Neural networks are designed taking an inspiration from how the neurons in our brain works and how they are connected. So neural networks have all of the neural networks have two layers, which one of which is the input layer, where you input the data into, and the output layer, where you will where the model will output a prediction or an insight regarding the input data. There can be multiple layers in between input and output layer. If there are multiple layers in between input and output layer, those kind of neural networks are called deep neural networks, which falls into the category of deep learning models. So let's briefly discuss what a classification problem is, which we are trying to solve today. So to do that, let's break down the paradigm of machine learning. So there are three branches in machine learning that are broadly discussed. The first one is supervised learning. Supervised learning is that you are supervised learning models actually are capable of getting a data set and the expected outcome of that data set, which we are calling labels, to generate a generalized algorithm that it can use to do predictions given a similar data point. Hope that was clear. There are two subcategories in supervised learning. The first one is actually classification, where the model will, the prediction that the model does will be a category or a class that the input data belongs to. An example of a classification task is classifying if a given image is a dog or not. The other type of other subcategory of supervised learning is regression learning, where the model will try to predict a continuous value given an input. So, for example, predicting a stock price will fall down to a regression task. The second category of machine learning, or second branch of machine learning, is unsupervised learning, where the model is given a data set without a set of labels or expected outcome of this data set. The task of the model will be to extract insights from the data set in a sensible way. So it's a little bit of broader idea, but one of the major application of unsupervised learning is clustering, where the task of the algorithm, the model or the algorithm is to group a given set of data points into a set of clusters, depending on they are considering their distinguishable features in the dataset. The last branch of machine learning is called reinforcement learning. Reinforcement learning models are designed to use actually not to use any input data to train, but to use a reward function and a specific task for it to do. So the idea of a reinforcement learning model is to perform a task and use the reward function to understand how well it performed and improve upon itself. So digging a little bit deeper into classification, we can identify two types of classifications. one of which is binary classification, where you will try to predict only one category given an input. So any validation task will, for an example, verifying if your fingerprint is yours or not, is actually a binary classification task. Multi-class classification is actually any other type of classification where you have multiple categories to predict. When we look at image classification specifically, you might have come across convolution, a special kind of neural network called convolutional neural networks. These kind of neural networks are designed specifically to extract insights from images. So they use special property of images which are spatial dependency. So which means that a pixel, two pixels that are nearby together have have a dependency to one another. So the convolutional layers in the convolutional neural networks are designed to extract that information and gather insights from that. Convolutional neural networks also have some fully connected normal neural networks at the end of their network to do a normal classification task that we need to do. Let's briefly discuss what transfer learning is also. Transfer learning is the practice of using a pre-trained model that is developed to do one task and reuse that model to do a separate task. Transfer learning relies on the principle that the initial layers of a neural networks learns very low-level features from the dataset. So low-level features can be transferred to for another task, because most of the time those kind of features that you are extracting will overlap when the tasks are somewhat similar. So basically, you can use a model that's trained for identify dogs to identify cats. Advantages of transfer learning is that the training time will be reduced because you are using a pre-trained model. You won't have to have a huge amount of data to train the models, and the performance or the accuracy of the model will also is improved. So let's start with our hands-on session, knowing the information that we have gathered right now. Before coding away, let's define the problem that we are going to solve today. So given an image, we are trying to validate the image is a bank check or not. It's quite simple task, but I think a lot of real world problems, you'll be able to find a lot of real world problems that you can solve with this kind of simple classification task. Mind you, we won't be doing any content validation of the bank check or bank name and other information validation, because it's little bit harder to cramp into this kind of smaller session. So the plan is to gather some data to for our problem and set up an environment that we can use to implement our model and train it. Do any improvement if we see necessary, and deploy the model that we have created. So let's get started. First of all, the data set that we will be using for our bank checks is this IDRBT check image dataset, which contains around 112 images of different checks issued from different banks. This is a very small data set that you can't do much if you are training a model from scratch, but since we are using transfer learning for today, we'll be able to do something with this set. So already, so this is the link where you can download the zip file. I have already downloaded it, and I have put into my Google Drive here. So you can see that there are very little number of images that we have here. And also one problem with this is that most of the images that we have, I'm sorry, it's not showing any previews here. Most of the images that we have is belongs to the same bank. So I think there are the checks belongs to, I think, 5 or 6 banks here. So extracting feature from this might be a little bit difficult, but let's see how well we can do with this. I have gathered a negative data set that to train our model as well. This data set contains some random images along with some documents that our model can get confused with a check, so that we can actually train the model to distinguish between a normal document and a bank check. So when you are getting into data science, you can't actually justify affording a new GPU, local computer to train your models. And the problem also is that the models we are using right now for machine learning are huge and can't be trained in a smaller, laptop computer with a small GPU. So to get into machine learning, I would suggest for you to use Google Colab, which is a free service that allows you to use Google's GPU servers to train your models and save the model to your place that you like. One caveat with Google Colab is that any workspace that you have will be reset after 1 day. So you'll have to work more sensibly and save anything that you don't need to use into somewhere else. So this is the welcome screen of Google Colab. You can create a new notebook here. I have created a small template that we can actually work on today. That where we will fill some input, some codes into. So let me open that. Okay, if you don't know what a Jupyter notebook, the Google Colab is actually a Jupyter server. So you will create Jupyter notebooks and work on them. If you don't know what a Jupyter notebook is, it's actually a Python kernel where you can write any Python code into. So any Python code that you execute will right here, you can execute here. One thing you will notice here is that initially when you open a Jupyter notebook, Google Colab will create a backend instance for you. So you will have to wait a little bit for that to be happen. Also, one thing you have to note regarding Google Colab is that initially you will be given a server without the GPU. You can change that, go into runtime here and change runtime type and select the GPU or TPU. TPU means a tensor processing unit, which is similar to GPU, but if you don't know what that is, you can actually use a simple GPU for your use case. A thing to note here is that if you are extensively using Google Colab to do some tasks over and over, Google will limit your availability of GPUs for you. So if you are an extensive Google Colab user, you won't be able to get a GPU server right away, and you will have to wait a little bit longer to get a server allocated. But there's a premium subscription to Google Colab, which is Google Colab Pro and Google Colab Pro Plus, where you will get priority when allocating, getting a server allocated. So similarly, you'll be able to run a simple command here. Let's try with preparing our data set for our use case. First of all, our data set is in our Google Drive. We'll need to mount that Google Drive into our Google Colab setup. To do that, you can use this simple command because the drive and the Colab is actually in the same actually maintained by Google, so it's very easy for you to mount a Google Drive here. So once you have run this command, it will ask you permission to mount the drive. And once this is done, your drive will be mounted into a root directory called G drive. I know where my files are, somewhere in data row. I will mount that. So I'll create a symbolic link of that directory into this home directory of my Jupyter Notebook environment here. So after doing that, I'll be able to see all of my data files here. I will also define my project path to this directory, which is inside content. So as I have explained earlier, our dataset is very small. It has only around 112 images. So we can't actually do much with this dataset. So what we'll do is we will try to extend this dataset by augmenting the images. So I have created a small script to do the augmentation. I will open that because it will take a lot of time for us to develop this. Anyway, if you need any of this, any of the, either the template that I'm using today or the image augmentation helper class, this file, let us know and I'll share those with you. So anyway, there are a few functions here to adjust the gamma of the images, shear the image, translate, rotate, scale, flip horizontally and or vertically, resize, that kind of task. So for each image, we will do these kind of augmentations, and we will generate a lot more data points with one image. Mind you, we will only be flipping images for negative cases, because flipped bank check shouldn't be actually accepted by our model. So with this helper function inside our home directory, we can directly import that and use that to generate the augmented data. I have already run this command, which takes a little bit time, and the data is stored in this augmented folder. So it contains a lot of data points, rotated, gamma corrected, scaled up or down, sheared, that kind of things. So that data set is in this augmented folder. So let's try to import that. So here we will be using Kera's image dataset from directory function to load the dataset. We'll have to give that the data directory, the size of the images that if we want to resize the images when we are loading them, whether we need to shuffle them, actually, which we need to do, because all of the images here belongs to the same original image, so we need to shuffle them so the model can actually learn better. A seed for the random, a randomizer for this shuffling and training and validation data split, and the percentage of the validation data that we need. So I have created a partial function here, and I'm extracting the training subset and the validation subset using image dataset from directory function. A small note about seed, using a seed. If you are actually doing some research on a model, you actually should need to use a seed, because otherwise on each run you will get a different data set because of the randomizer, so you won't be able to compare the accuracies that you are getting. So we'll run this, and we will get a training and validation data set. After this has been run, we will define our input shape for our model, which is 128 by 64, which is the same shape that we have given here to resize the images into. So the next task for us is to create a base model that we need to transfer the knowledge from. So for this, we will use a ResNet model. Which is actually a very famous model for multi-class classification tasks, which is trained with a huge number of data points. So we are hoping that we will be able to use that for our advantage. As I have explained earlier on our slide, the convolution neural network contains some set of fully connected layers at the top of the network. We actually don't need to include that when we are doing our transfer learning approach, because we are defining our own fully connected layers to match our requirement or match our output requirement. So we have an easy parameter to be set to false, so we won't be getting the top fully connected layers of the model. Here we also need to define the input shape of the model. Which is the input shape that we have defined. We also need to do some thing to this model, which is to mark the weights of this model as untrainable. So the reasoning behind this is that we are trying to use the features that are collected by this model and train few layers on top of this model without trying to train the model itself. Hope that was clear. If not, please let me know. I'll explain a little bit further. But anyway, the idea is that we are not trying to train the low-level features that are extracted by this model, but to train the high-level features that we need to identify. So let's execute this, and it will download the model and create it for us. One thing to note is that Google Colab actually have TensorFlow and Keras and other machine learning libraries pre-installed internally. So we won't have to worry about anything. If you need to install anything, you can actually get an access to pip using an exclamation point where you can run normal shell commands. So you can do some pip install something inside one of these cells. Okay, once we have our model figured out, we'll wire up some layers on top of this. Before doing this, that we'll need to create an input layer for the model. Like this. So what this does is that it creates the input layer that I have explained discussing neural networks. We will connect this input layer into our ResNet model. One thing we will define here regarding the model that we have created is we will mark the model as untrainable. Sorry. We'll mark the model as not training. So this is not the same as trainable. As I have explained, trainable. What trainable does is that it will make the way. It will lock the weights of this model. What training does is that in this kind of complex models, there are some layers or neurons that behave differently when you are training the model versus when you are using the model to do some predictions, or in other words, inferring. So when we define this model as not training, we will mark those layers to not to do any weird stuff when we are passing data through this model. This is very important because we are not trying to train our ResNet model, but use the output from the ResNet model to train our the layers that we are putting on top of this. So let me put in only one layer on top of our model, which is a global average pooling layer. A global average pooling layer, you can think of it as a layer that flattens the data that you are getting from the ResNet model. So if you have 2D or 3D output you are getting from the ResNet model, global average pooling layer will transfer that to a 1D array of outputs. Additionally, it will do some averaging between the outputs, but we don't need to get into much detail about that today. We will connect this layer that we have stitched to this layer. Again, we will define an output layer at the end of our wiring up. This will be a dense layer, which is actually a name for a fully connected layer. The number of outputs we need is 1. We are using a special kind of activation function for our final layer, which are called sigmoid activation functions, which is the go-to activation function when you are doing a binary classification task. We will stitch our output from the above layer into this output, and we are done wiring up our new model. Okay. Finally, we will construct our model using the blueprint that we have created with this wiring. To do this, you can call Keras model, and inputs our set of inputs. Let me define this. And outputs are the ones that we have defined also above. Okay. Finally, we will compile this model. What you are doing compiling a model is that you are defining an optimizer for the model, which the model uses to update its weights when training. So for the optimizer, we will use Adam optimizer, and you will also need to define a loss function, which the model uses to understand how well it performed regarding the output it has given. So we will use binary cross entropy loss function. We also need to identify how well our model performs. So we will define a metric to evaluate how well our model performs. So a metric we are using is binary accuracy. So with this, we can compile our model. So finally, sorry. Okay, change this, so we need to run it again. So let me do this once again. Okay, I think we should be good. Okay, I made a mistake here. Okay, let's run everything again, I think. Okay. Okay, finally. We have compiled our model. So I think we are running out of time. So let me quickly go through everything. We will we will actually import a TensorBoard into our Jupyter notebook here. So we can take a look at what's happening in our model. And we can actually use this command to embed our TensorBoard model, TensorBoard here. So we can take a look at when the model is running. I have created two callback functions. One is to update data, so we can check on our TensorBoard, and one is to checkpoint when the model is running. If it found out the validation loss is lower compared to the previous run, it will automatically checkpoint that model and save it. We will define how we are going to train the model. You can do that by using classifier.fit function. You will input your training data. Your validation data and the number of epochs or number of runs that you need to run the data through, and your callback functions. Need to run this. Okay, so we can see that the model is being run. This going to take a little bit time, even though we have used very small number of epochs. But let's let it run for one epoch maybe. So while this is happening, let me explain one of the problems that our model has, which is that we only have one layer that the model can actually train to do to learn what we need to do. This is actually not enough to be able to correctly identify what a bank check is and what it is not. So I have created a little bit more sophisticated model which uses some dense layers, some dropout layers, and batch normalization, so that we can get a much more accurate result. The learning rate of this new model is also reduced because we have a very limited set of weights that we have the capability to train, so we need to go slow. And our data set is very small, and we are using a huge number of epochs, so we don't need to overfit our model. So this improved model I have already trained, and I have saved, checkpointed here. So let's while this is running, let's actually take a look at how we can use that model to do some real world predictions. So here I have saved that model, and I have gathered some set of obviously invalid and valid data points. So let's see how well our briefly trained, within half an hour trained model performs. So first of all, I'm running this on a very limited laptop. So let's see how quickly that it can actually do this inference. We are going to load the model using Keras models.load. For each image, we will use convert that image to an array and extract the pixels from the image and use that image and pass that image to our model and to do a prediction. The prediction is actually is a 0 to 1 value. So we are using this threshold, which is 0.5, to predict, to classify it as a check or not. So if it's above 0.5, it's a check, and if it's below, it's not a check. So let's run this model. I already did that. Let's see what it gives us. So obviously invalid data, you can see it performs very well, giving it predicting as not a check. And for checks also, sometimes it has predicted it as not a check with actually very high confidence. So let's take a look at these images. First one is test 1. Okay, the second one and third one is test 3 and 4. So you can see that actually all of the images that are scanned images, it didn't have any problem classifying, but the images that has other objects in, it hasn't been able to classify it correctly. This is because our training data set is actually constructed with data with only scanned images. So that's why our model was not able to detect correctly classify these kind of images. So if you need to go from here and improve your model, you'll need to improve your data set by introducing these kind of images. So it will be able to generalize itself to be able to understand itself. Anyway, with a very limited data set and a very limited time, we were able to create a model that performs reasonably well in a real world scenario, and actually quite fast, considering the resources that is required to actually train a model. So with this, I think we can conclude our hands-on session. You can see our model is also trained. If I run this again, we'll be able to take a look. Yeah. So the output that we got from our initial model is not that good, but you can as we have seen, our newer model that we have trained with much few more layers was able to perform quite well in our real world application. So I think that concludes our session on using machine, doing some fast and easy machine learning with Python and Google Colab. If you have any questions, let me quickly take a look at the questions that we have.
So there's one question in the chat. One is, will the code be shared somewhere, and is this certificate issued? So Ahmed, to answer your question, the second part of your question, this is not a certificate issuing session. It's more of a workshop. So we hope that you take the learnings from this and apply it to whatever you are developing or starting at the moment. And Dulaj, I'll let you take the first part of it as to whether you will be sharing the code anywhere.
Yeah, I don't know how I can do that, but anyway, if you ping me through LinkedIn maybe, or through my email, I will be able to, I'll be happy to share all the codes that we have discussed today, actually.
Right, super. So guys, if you do have any other questions on machine learning or on the hands-on session that was just conducted, you can drop them into either the chat or into the Q&A section at the bottom. And I think we do have one question. Will the recording be available? Recording will be made available. We will be posting it on YouTube, and following today's session, we will also be sending it to you guys via email, along with a couple of other things for you guys to check out following today's session. In addition to that, thank you for joining. Do drop in any questions in the meantime into the chat box or the Q&A. And what you can also do is, if you want to stay updated on other events that Python Colombo organizes, or if you want to keep in touch with anything that Capstars organizes in the future, you can go and join the Python Colombo group on meetup.com, which I have just linked through in the chat. So if you go and join the group, you'll be kept updated on all the future sessions as well. We will also be sharing a feedback doc with everyone. So do let us know how you found this session and what other topics you would like to see us cover in the future. But in the meantime, if there are no more questions then I think we can go ahead and wrap up. So Dulaj, thank you so much for conducting this session for Python Colombo and Capstars. And of course, to everyone who joined us this evening, thank you so much for joining. We'll be sharing all the relevant material with you. Good night and stay safe. See you guys.
Yeah.
Oh, actually, before we go, we do have a question that has just come in. There's a thing that a strong foundation is compulsory to get into the field of machine learning. Could you provide a small explanation on this?
Yeah, so there are different aspects of machine learning where you can take on actually. So you can, in mathematical perspective, you can actually get into more in-depth architecture side of machine learning, and actually engineering side also. You can reuse the models available, the data sets available, and to tinker around and get to do the task that you need to do. So to do that kind of task, you actually don't need to have very in-depth understanding or knowledge about most of the things, because as of now there are a lot of libraries available that you can use. For example, Keras, as you have seen, it's extremely easy for you to set up something and get an output from. So after that, it all depends on your experience that you are gathering and the exposure that you are getting. So if you stay current with the development in machine learning and try to solve some problems in your organization or as a hobby, I think you will be just fine getting into machine learning and being an expert there.
Thanks for the question, and thanks for answering the last minute question as well, Dulaj. If there is nothing else, then we will conclude. Do keep in touch with us. Do stay tuned for what's coming next. And good night and goodbye, everyone. See you.
See you. Bye.